Hey, my name is Joshua Paul Maldonado. I'm from the United States. I'm a student over at MIT studying mechanical engineering with a focus on sustainability and global development.
Je m'appelle Ambre, je suis des États-Unis et j'étudie l'ingénierie mécanique. Donc je suis ici pour faire des recherches avec les poussins. Nous voulons créer une manière de les chauffer sans électricité.
You know, when we first received this project idea from Antenna Foundation, working alongside ASG, the problem was that local farmers couldn't afford the solar installations needed to be able to have a solar-powered heating system, which uses incandescent bulbs to be able to provide heat to these brooders. So we looked for an alternative solution that would be much less expensive, that would allow an entry for the local farmers to be able to heat their chicks. So it wasn't gonna, we looked into the box construction itself. We want to make sure that it was well insulated. So we have expanded polystyrene foam, which is sourced locally, that is layered within the walls to be able to retain any heat that we have coming into the box. We also wanted to change the heating method. The previous heating method was to use incandescent bulbs. We wanted something that was going to be able to be heated up and warmed locally without need for electricity. So we investigated different techniques. So we looked at radiant heating by pumping hot water potentially through a floorboard to be able to provide heat for the chicks. But that proved to be something that was too complicated to build, required plumbing experience, required materials that might not be able to easily source locally, like PEX tubing or copper tubing. The other idea that we had was being able to just heat the water on the roofs of buildings. That's really dependent on good weather, where you have enough sun to be able to heat up that water and cause heat-driven flow that's going to drive water up from below where you're heating the chicks and to pump hot water down. So that was also a really complex and expensive path. So we ended up using phase change materials, also called PCMs. These materials, when you heat them up, they melt. They change phase, and the heat that's involved in melting that material then will be discharged by material as it freezes. So things like water or wax or alcohols like tetradecanol or salts like sodium sulfate dihydrate. These are different materials that are used. Tetradecanol is specifically used for baby incubators. That's what we're looking for in a material that when it discharges consistently at a certain temperature, so we can have an expected range of temperatures for the space that it's pumping heat into. So our team first looked at sodium sulfate dihydrate because it had a lower temperature than body temperature, something that we were more looking for a range of 30 to 33 degrees. And we found that as that salt would be heated up, it would change. It's a two-phase material, so when it's actually melted, it's both solid and liquid. So you'll see grains of this salt alongside liquid solution that's also in there. But when that would freeze, sodium sulfate dihydrate hypercrystallizes. Like it crystallizes so quickly that it would pierce the bags that we were putting this salt into. So we wanted something that was less messy for the person to use, something that could be thermally cycled a number of times without having to worry about handling. So the team then looked into PCM, to wax as a PCM. So we investigated paraffin wax, and wax is commonly used for candles, to see if we could find a material that was easier to work with, that was less messy, that could be used without special packaging in the places that we were looking to use it. It performed really well. And then the next question was, how are we going to do this in Cameroon? That means, how are we going to locally source the wax that we need? So here we came across a beeswax, and we thought, well, let's try it out and see how it performs. And it performed really well. It held temperature for 15 hours, and we were looking for a range of 30 to 37 degrees Celsius. So yeah, that's kind of how we got here in terms of being able to use beeswax in this thermally insulated box that we have here in Obala.
Donc la première étape pour construire cette boîte, c'est de construire l'extérieur. Et on utilise les contreplaqués avec l'isolation dedans. L'isolation, c'est du polystyrène. Donc, il y a contreplaqué, isolation et contreplaqué pour protéger l'isolation des poussins. Et on construit toute la boîte avec les trois matériaux comme ça. Et on ajoute aussi des portes pour ouvrir et regarder les poussins. Et une autre porte pour avoir accès à la cire qui est dessus. Donc après qu'on a la boîte, on peut commencer avec l'étage pour les poussins.
So right now I'm verifying the internal measurements.
Okay.
Given, and we're going to construct a stage or a floor for the chickens to walk on.
Yes.
Out of chicken wire. This is going to rest underneath that, so when the chickens poop, it lands on here, and we can take this out and clean it.
Okay.
Il faut avoir l'aluminium avec le copeau sur l'aluminium. Il faut que les poussins peuvent avoir les lumières, donc les ampoules de LED sont nécessaires. Et après, il faut fondre la cire pour la première fois et mettre la cire dans les conteneurs. Et ça, c'est tout. C'est une boîte simple. On a assuré de trouver les matériaux locaux pour être complètement certain que la boîte peut être construite aussi par les locaux. Donc, on a trouvé la cire d'abeille et l'isolation et les panneaux à Yaoundé, même les ampoules, tout était trouvé en Cameroun. Sans l'engagement et la participation des fermières ici, la technologie n'est pas possible. C'était un projet avec notre université, mais aussi beaucoup des idées et des améliorations. C'était à cause des fermiers qui ont dit ce qui va être plus utile, plus efficace, etc., etc. Donc, c'est un produit vraiment camerounais et il faut, parce que c'est toujours en cours de développement, que les gens ici, ils construisent leur propre boîte et donnent des résultats et donnent leurs pensées, leur propre contribution pour que ça continue à améliorer.
Our hope when we leave is that this provides a real opportunity for farmers to provide an environment that is safe for their chicks, that allows less deaths due to sickness because chicks are being exposed to temperatures that are either too hot or too cold, and to give a farmer more time in their day. From our understanding, farmers will set a log on fire and monitor it for hours overnight, stay up with it to make sure that the chicks are not being burned or that doesn't go out. We want to provide a solution that requires a lot less maintenance, a lot less oversight, and can give farmers the time and the money that they need to go and continue to invest in their business so that they can have a box that is not only run by PCMs, but also a box that can have a solar option because they can afford the solar installations. So the idea is to continue to provide a good platform for farmers to grow their farm, their business, and keep all their chicks nice, safe, and healthy. You know, I think it's been super helpful to be here, to be on the farm, to be in Obala, to see what resources are available here for farmers. Back home, it can be hard to understand what's available, whether it be services or materials. Now that we're here, we've been able to source those things, see what materials are available in Obala and Yaoundé, to be able to know what services are available. Is there welding? Is there fabrication of like carpentry for boxes? And we were able to find a monastery that was able to do that for us here. And now that we've established these connections, these contacts, it gives students in the future from MIT who are helping D-Lab to develop these things to know what they have access to and to build stuff here even if they're overseas, to have connections with fabricators, to get things done, to do more testing here. I'm so grateful for ASG Antenna to be able to provide a forum like this where chicks can be exposed to these technologies and see and make sure that it works, so that farmers can come locally and see that it works. To talk to other chicken farmers and that their word means much more than my word does, so they can say, yes, we've seen it work with our own chicks. So I just want to leave here with people having confidence in the stuff that we've built, but also that they have a platform to continue to grow upon and to turn this into their own business. This is not something that MIT wants to have hands-on or to control. We just wanted to interject some technology, to interject some of the abilities that we have to make sure this stuff works, but for it to be something that's adopted and run by local farmers here.